This is a Seabird 9 CTD aboard the research vessel Seawolf. It measures conductivity, temperature, depth, and from those three parameters it derives salinity. It also measures dissolved oxygen, pH, turbidity, chlorophyll, and ambient light. It measures all these parameters, scans them 32 times a second, sends the data up our sea cable to our dry lab where we can look at the data in real time. And then if you see something that's of interest, either a depth layer or a spike in chlorophyll or something like that, then you can command one of these bottles, the General Oceanics Rosette Sampler, to close one of these sample bottles and take a physical sample for later analysis. This is the underway hydrographic instrument system aboard research vessel Seawolf. We start with the General Oceanics 8050 PCO2 system, which measures the partial pressure of carbon dioxide in seawater. It's used for ocean acidification measurements. In the coastal environment, this instrument measures great variability, much greater than you'd see on the open ocean. And in fact, the Seawolf is one of the smallest vessels in the world that carries this instrument. Moving along, that's the dry box for the PCO2. This is the wet box for the PCO2, where the water flows through and has the CO2 stripped out of it and sent to the dry box for measurement. Further over, we have a vortex debubbler, which removes nuisance bubbles from seawater, which would impair the accuracy of the instruments. Further down is a Sunburst Sensors AFTPH high accuracy pH sensor, a Seabird thermosalinograph, measures salinity and temperature, and then a Turner C3 fluorometer that measures fluorescence, chlorophyll fluorescence, turbidity, and CDOM, which is colored dissolved organic matter, which is used in water quality studies. Away from the water wall, we have a sea surface temperature sensor down in the hold, right where the seawater comes in, so we can accurately measure the temperature of the input water before it comes through the pipes. And we also have weather and navigation sensors up in the masthead. So in addition to any computers that the scientists will bring aboard the boat, we have a number of computing stations that are permanently installed aboard the Seawolf. We have this one, which gives a continuous real-time display from the underway system, wind direction, latitude, longitude, vessel heading, pitch, air temperature, barometric pressure, dissolved oxygen saturation, salinity, fluorescence, and so forth. Then we have this large display. Right now it's got the vessel navigation. We're in Port Jefferson, but you can switch that to, for example, show the CTD. So here's a saved CTD profile. So we can look at the CTD and have the scientists looking at the CTD in real time on this large screen, while the operator's over in the corner here taking care of the logistics to make sure that we don't anchor the vessel with it. So this instrument is a brand new addition to the Seawolf. It's just gone on in the last month or so. It's a Picaro gas analyzer. It measures atmospheric water vapor, methane, and CO2. It's being used in studies of measurements of the atmospheric plume downwind of the New York metro area. This is the readout from the Picaro. Shows that it's very responsive and very sensitive. In fact, those little bumps you see are the ferry from Bridgeport, Connecticut, coming into port, and the plume of CO2 from its engines actually makes the Picaro spike slightly. and the ferry dock is almost a half a mile away. So when the wind's blowing correct, we can actually measure the increase in CO2 in the area from a ferry boat pulling in and out.